Now let's discuss the definition of a vector or the cross product of two vectors, and we'll also discuss their properties and what parallel vectors are in this definition. So now let u and v be two vectors, and the cross product of the two vectors is basically the magnitude of u multiplied with the magnitude of v into sine theta into n. Now what is this n? N is a unit vector perpendicular to the plane of u and v. Now it's very important to understand this, because once you understand this, everything becomes clear. Now a very fundamental difference between cross product, the resultant of a cross product between two vectors, and the resultant of a the dot product of two vectors and the resultant of a cross product of two vectors have a fundamental difference, that a dot product is basically gives you a scalar value, and the cross product basically gives you vector value, right? So it has a direction, and that direction comes from this. Okay, and because obviously if you just take the magnitude of u, the magnitude of v, and the sine of the angle between them, that just gives you one value, which is a scalar, just like in the dot product, right? But since the cross product gives you a vector value, you need to multiply it with something to give you a vector value, and that is this n right here. And it is perpendicular. This n is the unit vector perpendicular to the plane of u and v, right? But it's also very important to understand why. Because you see, if you have a three-dimensional plane over here, this will really help you understand this later on. If you have this over here, say this is the x-axis, this is the y-axis, and this is the z-axis, right? Now, the dot product between x and y, this can be found by the right-hand rule. What you do is you curl up your right hand with the thumb pointing out, right? Now, the four fingers, except for the thumb, the four fingers apart from the thumb, if it says that you have to find x cross y, right? Sorry, x cross y, right? That will give you what? Well, it gives you that direction that the thumb is pointing towards. So if you it says that x cross y, now what you have to do is you have to curl your the four fingers apart from the thumb from x towards y, right? And then you will see that once you do that, it gives you the thumb points towards the positive z-axis. However, if it said y cross x, well, you'll curl your fingers in the direction y towards x, and that will tell you that once you do that, the thumb that is pointing out, it will point towards the negative z-axis, which means that will give you negative z. And this is a very important concept to understand. Once you get the hang of this, this becomes a piece of cake for everyone. You just try this out a few times. Try this between z and y, when it's z cross y, y cross z, x cross z, z cross x, and you'll understand later on. So u cross v is equal to the magnitude of u multiplied with the magnitude of v, sine theta, the theta is the angle between u and v, into this n, which is the unit vector perpendicular to the plane of u and v, right? Now n can be found by taking the cross product of u and v and the magnitude of the cross product of u and v, right? So this, again, this is a bit different. So sine theta you can just find by u cross v over the magnitude of u into the magnitude of v into this vector n. Basically from this can be just found from this first equation, right? And sine theta can also be found by this, the magnitude of u cross v over the magnitude of u into the magnitude of v. So now you have two formulas to help you find sine theta. But again, the most important thing is this concept over here. By using your right hand, you can find the direction of the vector n. Now, properties of cross vectors, again, u cross v is equal to 0 if u is equal to 0 and v is equal, pretty self-explanatory, right? Now, u cross v is equal to negative v into u, right? And that again can be explained by the right hand rule, right? Because if you see over here in the right hand rule, if instead of x, when you remember that x cross y, that means going from x to y with the thumb pointing towards the positive z, that just basically means that if you take negative x, if you take the negative of x, that means it is the negative x-axis. So from negative x-axis towards y, which is this direction over here, that is basically the same as y cross x, because it's going like this, right? The clockwise direction if you look from above, which is why my negative x into y is equal to wait just a second, let me just erase this off. So negative x cross y is equal to y cross x, which is equal to negative z, and that is what this property is. U cross v is equal to negative v cross u. And the third property is the distributive property, which says that u cross the sum of v and w is equal to, as if you basically take the cross product of u and v and add that to the cross product of u and w, right? And now here is another property which says that if you take the scalar multiple of v with k as the scalar, and then you take the cross product of their sum with u, that is basically equal to as if you take the scalar multiple of k with u, and then the result of that, the cross product with v. And all of this is also equal to as if you take the cross product of u and v and then multiply the result with the scalar k. And the fifth property is that u cross u is equal to 0. Why? Because u and u have an angle of 0 between them. So theta is equal to 0, which means that sine theta is equal to sine 0, which is equal to, you guessed it, 0. Now let's discuss the parallel vectors. If u and v are parallel vectors, that means that theta is equal to 0 and sine theta is also equal to 0. So u cross v, this is the fourth property that we discussed earlier. U cross v is obviously equal to u into v, the magnitude of u into the magnitude of v into sine theta into the vector n, which is parallel to u and v, right? And you know now how to find the direction of that unit vector. So u cross v is equal to 0, or v cross u is equal to 0 when they are parallel, because theta is equal to 0 between them. The angle between the two vectors u and v is equal to 0 when they are parallel, obviously. But so sine theta is equal to 0, or where u cross v is equal to 0 in three conditions: when sine theta is equal to 0, u is equal to 0, the magnitude of u is equal to 0, or the magnitude of v is equal to 0. If sine theta is equal to 0, theta is equal to 0 or 180, right? Because parallel vectors can have opposite directions as well. So the angle between them can either be 0 or 180. But again, it's the same thing. You need sine theta to be equal to 0. So sine 180 is also equal to 0, right? Because that's, if you just calculate sine 180, it gives you 0. So this, when sine theta is equal to 0, that means that u and v are parallel. Simple rule. If u is equal to 0 or v is equal to 0, then since the 0 vector has no specific direction, we adopt the convention that 0 vector is parallel to every vector, right? 0 vector is basically nothing, so it's basically parallel to everything. So that's just a very simple explanation. And but further, this is very important to remember this particular point. Since it has no specific direction, the 0 vector has no specific direction, that means that it is parallel to every vector. And so yeah, these are the two rules, and that's just it.